Good morning, 9th class students. Today we are going to learn about lines and angles. This is a very interesting, it's a fundamental, but very interesting and very fascinating chapter. I am very happy that I had the opportunity to teach you. Now, some of you already learned about some fundamentals about the lines and angles. Lines and angles. Now, first we go through the various definitions of in this chapter. First, let us see. The first one is the point. A point like that. This one you call it as point. P-O-I-N-T. Normally, it is represented by a letter P. Or you can call it as A. You can call it as A, or you can call it as B, or M, anything. But it has only one letter. It will be represented by only one letter. The next one you have is an arrow. An arrow. Or you call it as ray. I should not call it as arrow. Arrow is an example of a ray. A ray has one end point, and normally you call it as, let us say this is O, this is OM. So OM is the ray and you represent it like that. Okay, you cannot write like MO, it is wrong. You have to write, if the starting point is O and then M is there, so OM is the ray. Next you have what is a line. This is called a line. L-I-N-E, line. Line has no ends. This is unending. I may draw a line like this, and you, Kishore, you may draw it as long as that. And Praveen, you may draw a line like this. All these are lines. Lines do not have any endpoints. Then we have what is called a line segment. So let me erase this and then move on to the line segment. Line segment. Line segment is part of a line. So if you take a line like this, and if you mark 2 points, let us say PR. PR is 2 points. Then PR is a line segment. Segment entity mukka. It's a part of a line. A line is unending. It does not end, whereas segment has 2 endpoints. So PR is the line segment. Now you can call this as, mathematically, you can call it as PR with a line on the top. People may not every time follow that, so they may simply say PR. You can call it as PR or RP. It does not matter whether you read it in this direction or in this direction, it does not matter. So all you have to do is, when you are representing a line segment, all you have to do is identify 2 points on a line and mark them as, let's say, AB or PR or whatever, and then you can write like, you can show this line segment as PR with a bar on the top, or just simply PR. So bar is implied. So when you say PR, the line, part of the line starting from P and ending at R. That's why you call it as PR. Or you can say XZ. If you have XZ, suppose I have a line like this, one point is X and the other point is Z. XZ is the line segment. It is very important you know this line segment very well, because we use this number of times in dealing with the practical geometry. So this is the line segment. Then we also talk about a closed curve. A closed curve. A closed curve means if you start at one point, this is a curve, and you one point, and then you can end at the same point. If you can end at the same point, then you call it as a closed curve. The word closed implies that means it is not open. Closed means not open, right? Now, let us say a graph like a curve like that. That is open curve. This is a closed curve. Normally, when you say a line, it implies that it is a straight line. Unless you call it as a curved line, a line, it automatically means, line means it is a straight line. When you say straight line, and if you say a line segment, that means you are identifying already a portion of the line represented by two letters. Okay? And like I said, in the case of a ray, you have the direction is important. This is the starting point for the ray, and this is it's an aligning. Can anybody tell an example of a ray? You know, the sun rays start from the sun and they do not end. They keep on going. So that is the example for a ray. Now you have the line segment. So I taught to you in this class today. I taught you about what is a point, what is a ray, what is a line, what is a line segment, and then a closed curve and an open curve. Now we move on to, so again, once again, I taught you about a point. Point does not have any length, no end points. It's only one point. Whereas in the case of a ray, you have one end point and it keeps on going. The ray, you can call it as this one point. You can write it like that. You can write like this too. Now when you represent ray 0 or O, they are not 0. O and A, that means OA is the ray, and then you call it, when you write it down, it is like this. Okay? Anyway, now, so we learned about point and ray, line segment, closed curve, open curve. Now we move on to when you have two lines, what happens to, what kind of situations you will come across. When you have two lines, what kind of situations you come across. Now, suppose you have one line here, and there is another line like this. That means you call these two lines as intersecting lines. They are intersecting. That means they are intersecting at a point O, and this one a point O. Let us say O. This is called point of intersection. Point of intersection. INTERSECTION. Now one thing I forgot to mention to you, when you take a ray, a line, you call it as represented by the small letters, L, M, N, like that, R, A, B, C. So this is another line, M, okay, doesn't have any end points. So these two lines, L and M, are intersecting at point O. Now, so this point O is called the point of intersection. Now, suppose if these two lines do not intersect, they are at a constant distance all the time, they are at a constant distance, then you call them as parallel lines. I told you in the earlier, probably you already learned in the previous class, the example for the parallel line is the railway track, the bars in a window, or even, say, take this blackboard. There is a line like that, there is a line here. These two lines will never intersect. They go parallel. That means the distance between the point here to this point, and again the point between this distance between this point and the corresponding point there is always the same. So when you have two parallel lines, the distance between two parallel lines is always the same. Now, it's okay. Now, it's important thing that you need to know a little bit more about these intersecting lines. Now, when I told you that when two lines intersect, or they may intersect in any way you like. Suppose I can draw it like that, I can draw it like this, I can draw it like this, I can draw it like this. In any way you can draw, but the lines have to intersect and there must be a common point of intersection. Point of intersection. So I told you this point of intersection. Now, what we say is, when two lines intersect, let's say I will draw only part of this line, and this line, and I will draw another part of this line. These two lines meet at this point O. Again, you can call it as point of intersection. Here, the point of intersection. This is one ray, this is another ray. Then we call that an angle is formed. An angle is formed. Now, this angle can be, we have different names here. This angle can be acute angle, it can be right angle, and obtuse angle. We have some other names also. We will talk about that later on. Acute angle. In the case of the acute angle, here you can see the angle formed is less than 90 degrees. So in the case of acute angle, the angle is less than 90 degrees. Whereas in the case of the right angle, the angle is equal to 90 degrees. So what is obtuse angle? It should be greater than 90 degrees. Okay? So the angle when two lines intersect, this is one arm, this is one arm, this is the other arm. These two lines, the arms meet at point O. Let us say I can call this as OA and OB. OA and OB. So these two intersect at O and they make an angle AOB. We call it as angle AOB. Or simply, sometimes we call it as angle O. Angle O, when you want to represent angle, you should not write like this. It has to be slightly inclined and like this. And you should not write the letter outside the angle. It has to be here, inside only. So when you want to show an angle, it has to be inclined and the letter should be here, inside. That's how the angle is represented. Now, here I told you, in the case of if the angle is less than 90 degrees, it is an acute angle, and if it is equal to 90 degrees, then it's called a right angle, and then we have an obtuse angle. We also have some other terms like complementary angles, supplementary angles, adjacent angles, non-adjacent angles, and also a linear pair. So you have all different combinations. Just like when you have in a class, not everybody has the same name. Not everybody has the same name. One guy is Rama, another one is Thomas, another one is somebody else, like that. Similarly, for angles, you have different, like based on the value of the angle, whether it is more than 90, less than 90, or equal to 90, we have a classification. Now we call it as these are all single one angles. Now we talk about a pair of angles. That's when you call it as, then in that case we have what is called complementary angles, supplementary angles, adjacent angles, non-adjacent, and a linear pair. Now let me go back, let me explain what those three angles are, and then I will close today's lesson. And before, of course, they close the lesson, again I will summarize what I taught you. And here it is, complementary angles. Complementary angle, two angles are said to be complementary if the sum of the two angles, suppose if I draw a line like this, let us say this angle is 30 degrees. But if this is 90, then what can you say about this angle? This angle is 60 degrees. So, two angles are said to be complementary if the sum of the angles is equal to 90 degrees. I will call it, let us say, this is point of intersection is O, this is A, this is B, let us say this is C. Now, you can say angle AOB, angle AOB is equal to 30 degrees. Similarly, angle BOC, angle BOC is equal to 60 degrees. Right? Correct? Angle AOB is equal to 30 degrees, angle BOC to 60. Let us see what happens. Angle AOB plus angle BOC is equal to 30 degrees plus 60 degrees. So it is equal to 90 degrees. Therefore, these two angles are called as complementary angles. One is complementary to the other. That means the one is 40, the other one is 50. The one is 10, the other one will be 80. So that's how the complementary angles are defined. Then what you have is, the other one is supplementary angles. These are complementary. COMPLI, complementary, MENTARY. Complementary. So you have to divide it so that you can easily understand the spelling. Similarly, the next one, understand or remember the spelling. The next one is supplementary. SUPPLEMENTARY, supplementary. Two angles are said to be supplementary if the sum of the angles is equal to 180 degrees. Here for the complementary it is 90 degrees, whereas in the case of supplementary the angles have to be, sum of the two angles have to be 180 degrees. Now that means, let us say I will draw an angle here. For example, this is 30 degrees, let us say. This angle is 150 degrees. So 30 plus, again one is O, A, B, C. So here 30 plus 50 is equal to 180 degrees. 180 degrees. Okay, 30 plus 50 is 150 is equal to 180 degrees. So these two angles, here angle AOB and angle AOC, angle AOC, AOB plus angle AOC is equal to 180 degrees. So those two angles are called supplementary angles. Then let's leave the adjacent angles, non-adjacent angles, linear pair for this is part 2. Now it's important, so let me summarize what I taught to you today. First I defined what a point is, then I explained to you about a ray, then I told you about a line, and then I told you about a line segment, then I told you about a closed curve, then I told you about a open curve. Also told you this has no endpoint, no dimensions, this has only one endpoint, this has no length, and this has only two endpoints, and it has a definite length, a line segment. Where line segment is very, very important. Line segment is very important for understanding mathematics. We use that a lot of times, a number of times. So we have to understand the line segment very well. Then I also told you how an angle is formed. If the two lines are parallel, that means the distance between the two lines is always the same, then the lines are called parallel lines. That means they don't meet at any place. They are always at the same distance. So then we have intersecting lines. If the lines meet at one point, or intersect at one point, then the lines are called intersecting lines. And also I think one thing while I was talking about intersecting lines. One thing I missed to tell you is concurrent lines. CONCURRENT. Concurrent lines. Concurrent lines. Suppose if you have a point, 3 points, how many lines can you draw? You can draw infinite number of lines. So, Krishna, you draw like this. Mohini, you draw like this. Saraswati, you draw like this. And Venkateswara, you draw like that. So, they are all lines. They all pass through one point. If the lines pass through one single point, then the lines are called concurrent lines. So I told you about concurrent lines, and we talked about complementary angles, talked about supplementary angles, and so I hope you understood what I taught you. Normally in my class, I ask the students to ask me questions, but in this case, you are far away from me, so the only way you can ask me is send the questions to me by WhatsApp. My WhatsApp number is 789-361-4045. I can assure you that I will respond to you within 24 hours. I would love that. I love to teach, but I love more when you ask me questions. Sometimes you ask some questions that I may not be able to answer. That is a thrill for me. It's a big thrill for me. So my God, this guy is asking me a question which I don't know. So I will go through internet or go through library or do something or other, then I will finally get the answer. So students, the more you ask me, more I will be able to teach you better. Well, thank you very much.